Welcome back to the deep dive. Today, we are getting into, I think, one of the most fundamental tools in medicine, the complete blood count. Specifically, how it helps us diagnose anemia. Because our sources today really frame this not just as a lab test, but almost like a clinical story told in numbers, if you know the language.
That's a great way to put it. It's so true. I mean, anemia can feel like this massive, overwhelming topic,
Yeah.
but the sources really emphasize that if you're systematic about it,
Mhm.
you don't need to just order 100 tests right away. You can often get a presumptive diagnosis just from that initial CBC.
Okay, so let's unpack that. Our mission for this deep dive is to turn that complex CBC report into a clear sort of three-step map. We want to show how those big classifications, microcytic, normocytic, and macrocytic, really guide your entire thought process.
Precisely. And the key to the whole thing, the absolute first question you have to answer is, what is the MCV, the mean corpuscular volume? You can just think of it as the average size of your red blood cells.
So that's our starting line. And where you go from there, it all depends on that number.
It all depends on the size. If the MCV is low, you're looking at a microcytic anemia. If it's normal, well, that's normocytic anemia. And if it's high, usually over 100, you have to start investigating macrocytic anemia. That single number really dictates the next 20 questions.
All right, let's jump into that first world then. Microcytic. The small cells. This is the most common type of anemia globally, so the number one suspect is always going to be iron deficiency anemia, or ID. So if you're looking at a CBC, what's the dead giveaway for IDA?
Well, the obvious things are, of course, the low hemoglobin and the low MCV. You'll see a low MCH and MCHD2, which just means the cells are pale, not just small. But the real signature, the thing that really separates it from its mimics, is a high RDW.
The red cell distribution width?
Exactly.
Let's just pause on that for a second. The RDW, what is that actually measuring? And why does iron deficiency specifically make it shoot up?
So the RDW is basically a measure of variation. How much variety is there in the size of your red blood cells? If they were all identical clones, the RDW would be very low. In IDA, it's high because the deficiency is usually chronic. So you have this mix of cell populations. You have older, normal-sized cells that were made before you ran out of iron.
Ah, okay.
And you have the brand new, smaller, paler cells that the bone marrow is struggling to make now. That mix creates chaos and a high RDW.
So the high RDW is showing us the bone marrow's struggle over time. It's a history of the deficiency unfolding.
That's it, exactly. And you might see other things, maybe a high platelet count or those classic pencil cells on a blood smear. It's the classic picture you see with slow, chronic blood loss.
Okay, so here's the critical clinical question. Thalassemia, also microcytic, but a completely different cause, a different treatment. What's the trick on the CBC to tell it apart from IDA before you even order a ferritin?
This is where the systematic approach really shines. In thalassemia trait, the MCV is low, sometimes really, really low. But the key difference is the RBC count, the actual number of red blood cells. It's a structural defect, right, in the globin chains. So the bone marrow is actually very efficient at pumping out these little cells.
So you get a ton of tiny cells.
A ton of them. The RBC count is normal, or sometimes even high. So if you see a really low MCV, say 65, but the RBC count is high, like 6 million, you should be thinking thalassemia, not iron deficiency.
That's an incredibly high-yield distinction.
It is, and the RDW in thalassemia is usually normal because it's a consistent factory error, not a struggle. It's always making the same small cell. You might see target cells on the smear, too.
Okay, before we leave the microcytic world, two others. Anemia of chronic disease or ACD? How does that fit in? I thought it was usually normocytic.
It usually is. That's a great point. It only really becomes microcytic when the condition is very long-standing or the inflammation is severe. The mechanism is all about a protein called hepcidin.
The master iron regulator.
That's the one. Hepcidin basically thinks there's an infection, so it locks all the iron away in storage cells and the macrophages. The result is you have plenty of iron in the body, but the bone marrow can't get to it. So your labs will show low serum iron, but paradoxically a high ferritin because it's all locked up.
Fascinating. And very briefly, sideroblastic anemia.
That's a failure to incorporate iron into the heme molecule itself. The CBC can be really dramatic here. You get a very high RDW and what we call a dimorphic picture. Two different cell populations. You see it with things like alcohol toxicity, B6 deficiency, even lead poisoning.
All right, on to the next bucket, normocytic anemias. MCV is normal. So cell size is fine. The problem has to be either you're losing them fast, destroying them fast, or The factory is just not making them. This feels like a big category.
It is a big category,
Yeah.
which is why we have to immediately shift our focus. We're not looking at size anymore, we're looking at production. And the single most important test now is the reticulocyte count. Is the bone marrow responding?
Okay, so let's start with a high reticulocyte count. The factory is working overtime.
Right. High retics means one of two main things. First, acute blood loss. If you bleed suddenly, your hemoglobin looks fine at first. It only drops after your body replaces the lost volume with plasma, diluting everything out. The reticulocyte response, the marrow kicking into high gear, that comes a couple days later.
In the second cause?
The second, more complex one is hemolytic anemia, rapid destruction of red cells. The high reticulocyte count is just the marrow desperately trying to keep up with the destruction. And what's interesting is that reticulocytes are actually a bit larger than mature cells. So in severe hemolysis, the MCV might even creep up a little.
So with hemolysis, how do we narrow it down? The clues must be on the peripheral smear.
Oh, absolutely critical. The smear tells the story. You see schistocytes, those fragmented cells. You think physical trauma, like in TTP or DIC. You see spherocytes, little round cells. You think autoimmune hemolysis or hereditary spherocytosis. Bite cells point you towards G6PD deficiency. The smear is everything here, along with, biochemical markers like LDH and bilirubin.
Okay, let's flip to the other side. Low reticulocyte count, the marrow is suppressed.
Yes, and this is where you find some really serious chronic conditions. We already mentioned anemia of chronic disease. It's primarily normocytic with a low retic count because that hepcidin is blocking the iron release.
Right.
Then you have chronic kidney disease, CKD, and this one is very straightforward. The kidneys make erythropoietin, or EPO. That's the signal that tells the bone marrow to make red cells. In CKD, the kidneys fail, so no EPO, no signal. The factory just sits there waiting for orders that never come. So you get a very low reticulocyte count.
And the most severe case of marrow shutdown.
That would have to be aplastic anemia. It's just
Yeah.
complete bone marrow failure. And when you look at the CBC, the thing that screams at you is pancytopenia. Everything is low. Red cells, white cells, platelets, and of course the reticulocyte count is practically zero. It's a true medical emergency.
Okay, this is where it gets really interesting for me. Macrocytic anemias, the big cells.
Yeah.
MCV over 100. When you see that on a report, what is the immediate number one concern?
The immediate concern is always megaloblastic anemia. That's from a deficiency in either vitamin B12 or folate. What's happening is a problem with DNA synthesis. The red cell precursors in the marrow, they can't divide properly, so they just keep growing, bigger and bigger. The CBC will show a very high MCV and usually a high RDW as well.
But what's the one finding that really nails the diagnosis?
It's on the smear. You have to look for the hypersegmented neutrophils.
Yeah.
These are white blood cells with these big multi-lobe nuclei. If you see those, it's practically pathognomonic for B12 or folate deficiency. A huge clue.
So that finding is the ultimate shortcut. But our sources are pretty clear that we shouldn't get tunnel vision. Not every big cell is from a vitamin deficiency. What are some of the non-megaloblastic causes we tend to forget?
There are a few very common ones. First is just alcohol. Alcohol is directly toxic to the bone marrow. You'll often see a mild rise in the MCV, maybe 100 to 110, in someone who drinks heavily, even before they're truly anemic. Liver disease itself is another big one. You get excess cholesterol deposited in the red cell membrane, which makes the cells swell.
And what about hypothyroidism?
Yes,
Yeah.
That's another classic cause. It can produce a mild microcytosis, probably just due to the general slowdown of the body's metabolism.
And of course, we have to circle back to the simplest cause of all, the reticulocytes again.
The reticulocytes, exactly.
Right.
We have to remember they are larger than mature red cells. So if someone is recovering from a bleed or they have some ongoing hemolysis, they're going to have a high reticulocyte count. That alone can push the average cell size, the MCV, up over 100. Always check the retic count.
Okay, so let's bring this all together. Let's do a rapid-fire clinical summary for everyone listening. The CBC comes back. What's the process?
It's a triage system. First, you look at the size, the MCV. If the MCV is low, you're deciding between iron deficiency and thalassemia.
And the key there is the RDW and the RBC count.
Correct. High RDW plus a low RBC count points to iron deficiency. The struggle. Normal RDW plus a high RBC count points to thalassemia. The consistent error.
Got it. Now, if the MCV is normal,
You pivot. You need to check the reticulocytes. It's all about the factory's output. High retics means loss or destruction, so acute bleeding or hemolysis. Low retics means the marrow is suppressed. Think CKD, aplastic anemia, or chronic disease.
and finally, the big cells. MCV is high.
If the MCV is high, look for hypersegmented neutrophils on the smear. If you see them, it's B12 or folate until proven otherwise. If you don't see them, then you broaden your differential. Think alcohol, liver disease, thyroid problems.
It really is this powerful systematic interpretation. Just by connecting those few key numbers, MCV, RDW, reticulocytes, you can get so close to the diagnosis in minutes.
I agree completely. And, people like Dr. Yogesh have been saying this for years. The CBC isn't just a basic test. It remains the single most important, most fundamental diagnostic investigation we have for anemia. The amount of value you get is just immense.
So here's a final thought to leave you with. Consider how the body's own attempt to compensate for the problem is what gives us the clearest clues. Whether it's pushing out that chaotic mix of cell sizes and iron deficiency, or the immune system locking down iron stores in chronic disease. The pathology itself creates the signpost. It turns what looks like a biological failure into a clear diagnostic signal, and that signal is always right there on the CBC, just waiting for us to read it.